Okay, good. So today we are continuing with continuing with drawings and starting with section views. So, section views. Now the question is, why do we bother with sections? So far, we have done external views only, and external surfaces can be described fully by choosing the suitable views. But you might run into a case where complex internal detail will result in a large number of dashed or hidden lines, which may or will cause confusion for the person reading the drawing. Internal details also need to be shown or defined for manufacturing purposes. Remember, the idea of making a drawing is not and putting dimensions on is not so that you know how to draw it. It is so that someone else is actually capable of manufacturing the part exactly the way the designer intended. But if you just use hidden detail lines, it won't necessarily be adequate. Remember from the previous class, we don't dimension to hidden detail. So another strategy called a sectional view or section view is necessary for us to show the internal features. Okay, so a section view is a drawing that shows what a component would have looked like if it were cut open in that view. So we have a component, and now we imagine what it would have looked like if we had cut it open. So we cut it with a saw in this case. So we cut through it, and what's handy about this is sorry. What's handy about this is by making a sectional view, you'll notice we have these little lines. You can imagine those lines as the marks that the saw blade made as it cut through the material. The advantage of this is wherever it cuts, it means we, at that depth into the part, we are in a solid material. And wherever there is a hollow section, the saw marks will not be present. So this allows us to show where the component is solid, and it also allows us to show the internal details and dimension them, which is basically the whole purpose of making a drawing, that we can put dimensions on it. Thank you. Apparently it's page 45. So according to the previous lecture, I said that we show hidden detail for each feature in only one view. You can have hidden detail in different views, but for the same feature, like a cylinder at a specific location, you only show that cylinder in one other view. Okay, so if we draw it, imagine what it would look like if it was cut open. It allows us to dimension this internal detail so that the part can actually be manufactured the way we want it to be. So here I just have a quick example. This is a laser pointer that I built. So here we have the laser pointer. I actually built this so that I can lecture with it. So it's got an aluminium tube, it's got a power switch, and it's got a laser module. Now you'll notice the size of the laser is quite big. So it's actually a thick beam laser designed to make a big dot instead of making a very small dot. So I made this thing. Obviously it has to be hollow on the inside to take the battery and to take the laser and to take the switch. So if you want to have this thing manufactured, you can't just use the hidden detail to show the guy manufacturing it what it should look like. We'll have to do something else. So to have it manufactured, we do need to show the internal detail in a drawing, but the hidden lines are confusing. It's not easy to just understand what these hidden lines mean. Where do we have material? Where is it hollow? So what we will rather do, instead of having all of this confusing hidden detail lines, I would actually start with the basic drawing and do a section view. So basically what I'm showing here is if you take this laser and cut it through the middle vertically and remove this left hand side. If we then view this right hand view from the left to draw the main view, this is what we will see. So these little saw mark lines show us that the material is solid, and the blank spaces show us that those are all openings on the inside. So this is more a tube than what it is a solid feature. And over there we've got a little block cut out, which is the one that's cut out for the switch. And now I can actually go and dimension onto this so that I can have it manufactured the way I need to. Okay, so these hatching lines, we call them hatching lines. It's basically the mark that the saw made. They are parallel and drawn at 45 degrees. It can be either from bottom left to top right or top left to bottom right. We don't care. So as I said, you can imagine them like the marks that the saw made when cutting through the material. Everywhere where the blade cut, you will see the marks, but if there is an opening or a hole in it, the saw blade would not make marks there. So that allows me to show open spaces or hollow spaces and solid spaces. These lines are drawn using your thin pencil with similar spacing and angle for the whole section of that part, as would be the case when a saw blade makes a cut. One cut will make one cut pattern or style throughout the entire part. So technically, yes, hidden detail lines are allowed to cross over each other, but you'll just have to remember that that will cause additional complexity in reading the drawing, so it will make it a little bit more confusing. That's why, if possible, you will do hidden detail for one feature in one view and another feature in another view, that we don't overlap those hidden details. Yes, basically the hidden lines don't represent the hollow part, they represent an edge. So a change in something. And that's the whole problem with using hidden detail, because we can't tell if it is hollow and on which side it is hollow. So the question here was, why did I give that angle? Well, basically that just relates to the little cone that was made over there. If I wanted to, I could have specified it to be a 90-degree angle, just like a sharp hole. But for this laser example, using a drill to drill out the inside up to the tip there was actually considered acceptable. So if I specify the 120 degrees, then the person who makes this can see, okay, that's a standard drill tip angle, so I can just drill it up to that depth, and then I'm fine. Okay, so cutting this thing open now allowed me to show where it is hollow and where it is solid. and it allowed me to give all the dimensions necessary to be able to manufacture this thing. Okay. Remember, we give dimensions for manufacturing purposes, not for drawing purposes. Yes, so for practical 2, you have to only show the hidden detail. For the orthographic part has a hole drilled through it, so the hidden detail for that you can show either in your right-hand view or in your top view. So basically what I meant with this example was if we want to make a section view, this right view, imagine now if we cut it with a vertical line from top to bottom through the middle of the right-hand view, and then we erased this left half of the right-hand view. Then if we view this view from the left-hand side to draw the main view, this is what we will see. So that's basically what I meant. Okay, cool. So section types. Depending on what you need to show, there are different ways to actually make a section view. We have standardized ways to make section views. And we're going to look at some of them today. So the first type is a full section. Then we have a half section, revolved section, removed, offset, aligned, and partial section. These section types allow us to show internal detail of objects in various convenient ways. Yes, so hidden detail is shown in only one view for each feature, meaning if you show the hidden detail for the whole in two views, then you will lose a mark or two for that. So yes, we do show center lines on isometric drawings, but only in the plane of the cylinder, not in the axial direction. Okay, back to sections. So the first one we'll have a look at is a full section view. Full section basically means the entire view is a section view. So we make a cut at some other location. This is like a plane in which the cut lies. So everything in that plane is cut through. Now it's important to note over here, the center line there is used to indicate the section plane, and the arrows are used to show the viewing direction. So we are viewing this from the right to the left. So if we view from the right, we draw on the right, meaning that arrow indicates a right-hand section view. And we're cutting it through there. So we cut it through this vertical rectangle on the left and through the vertical rectangle on the right, with the center portion being open, that we can see the background detail, the little hole there. So that is a full section view. So remember the arrow direction, as I already mentioned. If the arrow pointed in the other way, it is a left-hand view. So we're viewing from the left to that line, then we'll see that. So obviously in this case, making a left-hand section view is kind of pointless. Okay, axial just basically means in the direction of the cylinder, not in the plane of the circle. So in an isometric view, you guys will show this center line across for the circle. But you will not bother to show the one in the axis or axial direction of the cylinder. So center lines are shown in all of the views. Okay, hidden detail and section views. We don't show hidden detail in a section view unless absolutely necessary, but generally for MGC's purposes, you will not show hidden detail in a section view. The whole point of making a section view is that you don't have to make hidden detail and you can show solid and hollow portions directly in the view. So adding hidden detail to a section view would kind of be counterproductive. Then secondly, the hatching lines, these lines that we use to show where the saw blade touched. Usually we do them at 45 degrees, but if there is a large part of the component that is oriented at 45 degrees, then we need to change this angle to, let's say, something like 60 degrees or 30 degrees, just so that we don't have a lot of our hatching lines parallel to the lines in the component. The reason for that is it can actually cause confusion. So let's say we had this component, it had a hole drilled through there, and it had a small hole drilled in there. So now if we go and draw these lines parallel to the big part of the component, then it would be hard to see that there's a hole over there. If I did it at a different angle, then it's very easy to distinguish between hollow sections and solid parts. So the question was, can't we just make the 45 degrees in the other direction? We could, but then again, it's getting a bit tricky to distinguish which of these lines is a hatching line and which of them is actually the hole. Then you have to start to look very carefully at line thicknesses, which gets a bit tricky to do as well. So remember, if you have a small hole touching the bigger one, then the hugging around will not really take place, so we can't really show that little thing. Okay, so there I've shown it, which is too small to really bother. But because we cut through that hole, we can't use hidden detail for the hole because it's actually physically visible. So it has to be a solid line, which brings me to my next point, which I'll do in a slide or so. So we have this component, we're making a full section view of this, so that is what it looks like. All the hatching lines are parallel and in the same direction. It is considered incorrect to have the hatching lines not in the same direction. Later on, we're actually going to use different angled hatching lines to distinguish between different components when we have more than one component in a drawing. Next thing is, it is considered incorrect to show something that is now visible with hidden detail lines because it is physically visible if the component is cut open. So it is considered incorrect to show these edges using hidden detail lines. Okay, so the center line is used for a couple of different things. It can be used, like in that case, to show the center of that little cylinder. But this vertical center line, well, I call it a center line because it's long, short, long, short, long, short. But it's actually a section plane. So we use the same type of line to indicate a center of a cylinder, and we also use that same kind of line to indicate a section plane. So if you go check in your line alphabet block, in the description it said that the center lines, or chain line, I should probably rather use the term chain line, that the chain line is used to show cylindrical features like that one over there, but it can also be used to show section planes. So that's why we used the section line over there. Yes, exactly. We used it to show where we cut the box. We will not ask you to do sectioned isometric views, that just gets too complicated. Okay, so background detail that is now visible should be drawn with solid lines. Please remember that now that it's cut open, I will actually see that cylinder there and the bigger one at the top and that one there. So those three lines will now be visible because the component is cut open. So it's considered incorrect if you forget to show the background information. Okay, so this is just a summary to show what's going on. A single object is to be hatched consistently, hatched with the same angle and spacing all the way through. Don't change the angle because we're going to use that later on for other stuff. Don't forget the background detail like this one, and don't draw the background detail in hidden detail because now it isn't actually hidden. When you have to dimension inside of a drawing that has hatching in it, don't do hatching over the dimension value because it will be hard to actually see where it is. What you can do is you can erase a little dot around the dimension value, or you could place the dimension on the outside. This is the better option. Okay, so the semester test content is actually shown in the daily timetable, the one that's on ClickUp. Under test 1, it says manufacturing up to casting 2, isometric, ortho up to and including dimensions. So that is what is in test 1. Thanks, Mr. Anderson. Okay, just some more dimension stuff. This kind of feature is called a chamfer. So it's when there's a hole in a component and you just make the hole not have a 90-degree sharp corner, but 235-degree angles. So the chance of something getting stuck in a 90-degree sharp corner is a lot higher than something which gradually slopes in. So it assists you to place the component, the shaft in the hole more easily, and it also allows it to guide in smoother as well. And this is just the way to indicate these angles if you wanted to. Okay, the next kind of section is called a half section. So you'll remember the previous one, full section, is the entire view is in section. But there is a bit of an advantage of doing an external view to show these lines going through horizontally. But there is also advantage of showing the internal details. So a half section view is actually a combination of a section view and an external view. Usually half sections are applied to components which are symmetric, meaning if I drew half of the external view, I know what the other half should look like. And if I drew half of the section view, I knew what the other half should look like. So this allows me to show two views, the full section and the external view, in one, doing more work with less effort. It's important though to note that the symmetry plane is used to distinguish between section and not section. Obviously, it doesn't matter which side is the section and which side is not the section. It depends on the question. And also the center line is, or this chain line is just a chain line. It doesn't have a solid line going through there. Let me quickly explain why. So consider this component. So it's a pipe with a little wedge that was cut out of it. So if I make a section view of this, like a half section, then this edge will actually cause the solid line. So in this one's case, the solid line has to be there because something is actually happening over there. But if it was a solid one, then we won't show this solid line, meaning if it was just a normal cylinder and I cut away the left half of it, then then we'll draw it like that. So then there will not be a solid line there. So that's why it's important to not draw a solid line in the middle of this component. It will be misleading. So it's misleading to have the solid line there. Okay, just one thing with the hatching. There is one rule though that says hatching is always bounded by a solid line. So hatching is not allowed to just end against a chain line, it must be bounded. So for this component, where the hatching touches the center line, you do a solid line over that part of the chain line. So casting 2 means up to and including the stuff that was done in casting lecture number 2. Okay, so remember the hatching lines do not end against the chain line, they have to be bounded. Almost consider them like water. There has to be a container around them all the way, otherwise it will leak out. So hatching line is basically just this thin lines that the saw blade made when we cut the component. That is the hatching line. Okay, cool. So the next kind of section that we're going to look at is a section called a revolved section. So a revolved section is used to show the cross section of an elongated object. Let's say we had that component on the screen. In 3D it looks something like that. But between this section here and that part there, the cross section there is consistent. So it's the same cross section between those two sides. If I wanted to have this thing made, I would actually need to specify what it looks like inside there. So what I do then is one thing that I can do if I want to show what it looks like or what the cross section looks like there is I can go and make a full sectioned right hand view. Okay, so I can show what the cross section over there looks like by making a full section right hand view. But this means I have to make an additional view. Remember, we label section views, something like that. So this wasted some space on my drawing sheet. And because there's nothing really changing from this side to that side, I can actually use this space to put my section view inside of my normal view. Okay, so there's my normal view. Then I go and section view, that section view AA, I can actually go and so instead of making a complete extra view, I can place that view inside of this one. So it's basically showing more information with less effort. Okay, so basically to just quickly say this again, a full cylinder, if we do a half section with the left half in section, then the center line will be through the middle to show that the left half is in section and the right half isn't. That rectangle just shows where I cut. So I basically cut this corner off of the component and then drew what it looks like if I view it from this side. Now if there was something happening over here, it will actually create this solid line. There's my center line. So basically, when we are making a half section, it's important to note that you don't show a solid line in the middle, because that might actually advertise information that is not necessarily happening. Okay, fair enough. I changed my solid line to a chain line. I just wanted to show the section plan. I didn't really pay too much attention to the detail of the line. But yes, it should be a chain line. So out of these two, making a full section side view or just doing a revolved section, this one would be the preferred one due to the fact that this section view allows me to show information without occupying space that I could have used for a different view. So then this one would be the preferred one in this case. If you have an elongated object with a constant cross section and you don't want to bother making a complete extra view. So the arrows point to, you say the direction we are looking at or looking from. So it is the direction we are looking at. So basically the arrow says this line, we are looking at that plane from the right hand side, meaning there's the eye looking at it from the right hand side. So yes, I could have explained this a bit better. These wavy lines are continuous thin freehand lines used for breaking of long objects. So those are the break lines. So I just broke a portion out, turned it 90 degrees, and drew what I saw. A chain line is the same as a sentence. Correct, yes. It is called a revolved section because that inside of the other view. So in this specific example, the inside has a little circle in it because there is a hole in there. So the person manufacturing this must actually make sure that he drills a hole through the center of that component. The mark for the previous prac should be out by tomorrow afternoon or so. Yes, exactly. The brake line is a continuous thin freehand wavy line. There is no specific shape to it. So the next kind of section we're going to look at is the removed section. So that's when you aren't always capable of placing a revolved section. So because we are just drawing the cross section, it can be viewed from the right or the left. The section view, that section view, whether I viewed it from the right or from the left hand side, would have looked exactly the same because it's a constant cross section all the way through. So I can take it, turn it that way, or turn it that way. It is the same thing. Prac 2 is due tomorrow evening, I think. So it depends on what you want to show, or in MGC's case, what the question asks for. Whether you're going to do a full section or half section. Usually for a symmetric part, half section makes more sense because then you do an external view and an internal view at the same time. On the right hand side here, we've got something called a partial section. So that is used if you just want to show a local detail, what something looks like in a specific region, so that you don't have to hatch the entire view, just do it in a specific region. We're going to have a look at that in tomorrow's class as well. Not tomorrow, but your next class as well. I'm not sure if it is tomorrow. Removed section is similar to the revolved section, except that it doesn't have to be in the part. It can be moved outside somewhere. So for example, this thing goes from an oval shape to a circular shape, and you can show that by means of this kind of section view. We're going to revise this in the next lecture as well. Okay, so now we've gone through all of the content for today's class. Are there any questions on what we've done so far? If you have to use a ruler, I suppose you can, but just make sure that it doesn't take you longer to do a line with a ruler than what you can if you do it freehand. The best way to revise these rules is to just read through the lecture slides, I would say. If you have the textbook, read through that as well. It does, in some places, explain it more in detail than what I just did. although I think what I just did should be more than enough. You can do the revolved section with cylinders. Yes, you can do it with any cross section that doesn't change much throughout that local region. How long do you need per drawing? I'm assuming you're speaking about the semester test. So typically the semester test will have isometric and orthographic with dimensions and manufacturing. So give 1 hour for manufacturing because it's about a third of the marks, and that means it's a third of the test. Then about half an hour or 40 minutes for the isometric and the rest for the orthographic. So I would say if you can do an orthographic drawing with dimensions in about an hour or an hour and 20 minutes, then you should be okay. In removed section, the result will be the same regardless of the viewpoint, same as revolved section. Yeah. Basically, the cross section of the part at that location, we don't care about the background detail. So yes, it will be the same. Doesn't matter from which side you wanted to look at it. For cross sections that are not consistent, you can use a removed section. Yes. Well, technically, when drawing any circle, you only show the circumference. But when you're drawing an isometric cylinder, depending on what the question asks for, you can draw something like that. Some bad line work over there. Okay, so the lines over here are called break lines. So we draw them purposefully not straight, we draw them wavy to make sure that the person reading the drawing can see this is not something that they have to machine out or something. This is literally just me showing a side view of the cross section. So a break line shows that I'm doing a drawing thing, I'm not doing a manufacturing thing over there. I'm not sure what 4 lines on the outside you are referring to. So the center line for this isometric will be done in that way.